Your refrigerator dies. The power stays out for 3 days. You open the door and the smell hits you first. Rot, decay, bacteria multiplying in the warmth. The chicken you bought yesterday is already slimy. The ground beef has turned gray. Within 72 hours, everything is garbage. Now imagine living in 1450 when a single pig had to feed a family of 7 through an entire winter. No electricity, no refrigeration, no grocery store 3 miles away. Yet somehow, that pork stayed edible from November slaughter to April thaw. The meat didn't just survive, it remained safe, nutritious, and central to survival in a world where food security meant the difference between living and starving. Medieval households possessed knowledge that most modern people have lost entirely, and that knowledge wasn't superstition or luck. It was systematic, tested over centuries, and so effective that professional butchers and charcutiers still use variations of these methods today when they want meat that lasts. Medieval preservers couldn't explain osmotic pressure or bacterial cell walls, but they understood cause and effect with precision. They knew that meat packed in salt stayed good while meat left in open air rotted within days. They observed, adjusted, refined. What they discovered through experience was a chemical process that modern science can now explain, but cannot improve upon in terms of basic effectiveness. Bacteria need water to survive. Their cellular processes depend on moisture to transport nutrients, eliminate waste, and reproduce. When you pack meat in salt, you create an environment where water molecules
against the grain,
areas of low
like
salt
this,
concentration.
and the salt,
Inside
it
the
must be
bacteria
coarse
and
to
the
draw
meat
the
toward
moisture
areas
out.
of high salt concentration. The salt draws moisture out through osmosis, the same principle that makes your fingers wrinkle in bath water. As moisture leaves the meat, the environment becomes increasingly hostile to any microorganisms trying to establish themselves. The process had to start immediately. In a medieval household, slaughter day was organized chaos. Animals were killed at dawn, while temperatures remained cold. Blood was caught in buckets for making blood sausage. Organs were removed and either cooked immediately or preserved separately. The carcass was butchered into portions within hours, not days. Speed mattered because every hour of delay gave bacteria more time to multiply. Fresh meat has bacteria on its surface, that's unavoidable. But if you salt it while bacterial populations are still minimal, you kill them before they become a problem. The initial salting used what workers called killing salt. This was a heavy coating, almost a crust, applied to every surface of the meat. Nothing was left exposed. Butchers rubbed salt into crevices, folds, around bones, anywhere moisture might collect. The meat then rested for a full day while this first application did its work. Salt dissolved into the surface moisture, creating a saturated brine right where it mattered most. Within 24 hours, you could see and feel the difference. The meat's surface became slightly tacky, firmer. Liquid pooled at the bottom of whatever container held it. That was the moisture being drawn out, carrying bacteria with it. After the first day, workers wiped away the dissolved salt and accumulated liquid, then applied fresh salt and packed the meat into barrels. This second salting used slightly less salt because the meat was already partially cured. Pieces were layered with salt between each layer, arranged to minimize air pockets. Air meant oxidation and potential spoilage. Tight packing with complete salt coverage ensured preservation. Over the next week, workers periodically drained more liquid that accumulated at the barrel bottom and added fresh salt to maintain concentration. By the end of 2 weeks, the meat had lost significant moisture, and the salt had penetrated deep into the tissue. Salt worked, but not in isolation. Temperature determined whether preservation succeeded or failed. This is why medieval Europe developed such specific traditions around when animals were slaughtered. The timing wasn't arbitrary or purely practical. It was essential for food safety. In England, France, Germany, and most of Northern Europe, the traditional pig slaughter happened between late October and early December. This period was called Martinmas in many regions, referring to the feast of Saint Martin on November 11. Farmers and households marked their calendars for this time, because it offered the sweet spot of cold weather without the harsh depth of winter. Temperatures during these weeks typically ranged between 35 and 45 degrees Fahrenheit during the day, dropping to near or below freezing at night. This range was ideal. The cold slowed bacterial growth dramatically, giving salt time to work. But the temperature wasn't so cold that it froze the meat solid, which would have made butchering and salt penetration difficult. Storage locations were selected with the same care given to slaughter timing. The best cellars stayed naturally cold year-round. These weren't the damp, moldy basements of popular imagination. A good storage cellar was dry, cool, and well ventilated. Many were dug into hillsides where earth provided natural insulation. The north side of buildings was preferred because sunlight never reached those areas, keeping temperatures stable. In castles and monasteries, meat storage often occupied underground chambers specifically designed for this purpose. Stone walls, earth floors, and careful positioning created environments that held steady between 45 and 55 degrees even in summer. Humidity mattered as much as temperature. Too much moisture in the air meant salt absorbed water from the environment rather than from the meat. This reduced preservation effectiveness and could even lead to salt dissolving and running off the meat's surface. Dry cellars were prized. Some households hung bundles of dried herbs or placed containers of fresh salt around storage areas to absorb excess humidity. Ventilation allowed air circulation without creating drafts that might warm the space. Small windows near the ceiling, openable only in winter, provided airflow. In summer, these stayed closed and sealed to keep the cool in. Regional variations in climate meant different preservation approaches. In Scandinavia, where winter temperatures regularly dropped well below freezing, households could rely more on natural cold. Salted meat was sometimes buried in snow or stored in ice houses where temperatures remained at or near freezing for months. In warmer regions like southern Italy or Spain, preservation became more challenging. There, people relied more heavily on combining multiple techniques, heavy salting plus smoking plus drying, to achieve the same results that northern Europeans could accomplish with salt and cold alone. The geography shaped the methodology because the principles remained constant. Bacteria grow in warmth and moisture, so eliminate one or both. Salt removed moisture. Smoke added protection. These weren't competing techniques but complementary ones, and medieval households understood how to use them together. Smoking wasn't about flavor, though flavor resulted. It was about creating a surface on the meat that actively resisted decay. The smoking process began after the initial salt cure. Meat destined for smoking spent 2 to 3 weeks in salt, following the same procedures used for salt curing alone. After this period, excess salt was rinsed off with cold water. The meat was then hung in a smokehouse, a dedicated structure, not just a room in the main building. Smokehouses were typically small wooden buildings with a fire pit at ground level and racks hanging above at different heights. The fire burned continuously but slowly, using hardwoods like oak, hickory, beech, or fruitwoods such as apple and cherry. The smoke had to remain cool. Hot smoke above 90 degrees would cook the meat, causing fat to render out and creating conditions for spoilage rather than preservation. Cold smoking maintained temperatures between 65 and 85 degrees, allowing smoke to envelop the meat over days or weeks without heating it. The compounds in wood smoke, phenols, formaldehyde, and various acids, settled onto the meat's surface and penetrated a few millimeters deep. These compounds were toxic to bacteria and created a protective barrier. Smoking duration varied by meat type and desired preservation level. A small cut might smoke for 1 week. A large ham intended to last 6 months might hang in the smokehouse for 4 to 6 weeks. During this time, workers tended the fire constantly, adding wood as needed to maintain smoke production without creating flames. The smoke needed to be thick enough to see, a visible haze that indicated active preservation. Too little smoke meant inadequate protection. Too much meant creosote buildup, which made meat taste bitter and potentially toxic. The result was meat with a hard, dark outer layer, almost bark-like in texture. This pellicle was the armor. Beneath it, the interior remained relatively soft but thoroughly preserved by both the earlier salt cure and the smoke penetration. When a household wanted to use smoked meat, they typically soaked it in fresh water for several hours to rehydrate it partially and reduce the intense salt and smoke flavors. The outer crust might be cut away or left depending on the recipe. What remained was meat that had been fundamentally altered in its chemistry, made hostile to decay through systematic human intervention. One preservation method that has almost entirely disappeared from common knowledge involved sealing cooked meat in rendered animal fat. This technique appeared across Europe under different names. The French called it confit, but the principle remained identical. Fat creates an airtight seal, and without oxygen, most bacteria cannot survive. The process required cooking the meat first. Pork, duck, goose, or other fatty meats were ideal. The meat was cut into portions and cooked thoroughly, either by frying in its own fat or by roasting until completely done. This initial cooking killed surface bacteria and drove out moisture. The cooked meat was then packed tightly into clay pots or wooden containers, arranged so pieces fit together with minimal air gaps. Hot rendered fat, usually lard from pigs or fat from the same animal being preserved, was poured over the packed meat until every piece was completely submerged. The fat layer needed to be at least 1 inch thick above the topmost piece of meat. As the fat cooled over several hours, it solidified into a firm seal, excluding air and creating a preservative environment. Meat preserved this way could last 4 to 6 months in a cool cellar. The fat seal remained solid in temperatures below 60 degrees, maintaining the airtight environment. When a family needed meat, they would carefully scrape away the fat layer at one spot, remove the desired amount of meat, then reseal the opening with fresh melted fat. The remaining meat stayed preserved. This method offered advantages that pure salt curing couldn't match. The meat retained more of its original texture because it wasn't subjected to months of salt exposure. It didn't require extensive soaking before use. The taste remained relatively close to fresh cooked meat, without the intense salt and smoke flavors that defined other preservation methods. Additionally, the fat itself remained useful. It could be melted down and used for cooking, carrying subtle meat flavors with it. In households where every resource mattered, this dual-purpose approach, the fat preserves the meat flavors the fat, made economic sense. The technique required more initial work than simple salt curing. Cooking the meat, rendering the fat, packing everything carefully, pouring the seal, all of this took time and attention. But for families who wanted variety in their preserved foods, or who needed to keep meat for special occasions rather than daily meals, confit-style preservation offered a valuable alternative. In specific regions where climate permitted, meat could be preserved through controlled drying with minimal or no smoking. This technique required conditions that northern European climates rarely provided, but that appeared naturally in mountainous areas of southern Europe. Northern Italy's Alps, parts of Spain, certain valleys in Switzerland. These regions had the right combination of cool temperatures, low humidity, and steady air circulation that made air curing possible. The process started similarly to salt curing. A whole leg of pork or other large cut was buried in salt for 2 to 3 weeks. The salt was changed periodically as it drew out moisture and became saturated. After this initial cure, the salt was thoroughly brushed away, and the meat was hung in a dedicated curing room where air could circulate around it constantly. These curing rooms weren't heated and weren't sealed. They had windows or vents positioned to catch prevailing winds. The movement of air carried away moisture that evaporated from the meat's surface, preventing the stagnant conditions where bacteria might survive. Temperature needed to stay cool, between 50 and 60 degrees, but not cold enough to stop the drying process. Humidity had to remain low, usually below 70%. When these conditions existed naturally for months at a time, meat could slowly dehydrate in place. Over the following months, the meat lost 30 to 40% of its original weight as water evaporated. The outer surface darkened and hardened. The interior became increasingly dense as water left and proteins concentrated. Sometimes, beneficial molds grew on the surface, white or grayish growths that created an additional protective coating. Experienced curers recognized which molds indicated successful preservation and which signaled problems. The beneficial molds were encouraged, even cultivated, because they added flavor and helped prevent harmful bacteria from establishing themselves. The entire process could take 9 months to 3 years depending on the size of the meat and the desired intensity. During this time, the meat underwent enzymatic changes as proteins and fats broke down slowly, creating complex flavors that fresh meat could never develop. The result wasn't just preserved, it was transformed. The texture became dense and slightly translucent. The flavor intensified, concentrated, developed notes that ranged from nutty to sweet to deeply savory. This method demanded knowledge that couldn't be written in recipes. Curers had to read the weather, judge humidity by feel, recognize mold types by appearance, adjust ventilation based on seasonal changes, and determine when meat had dried sufficiently without becoming overly hard. It was a craft that took years to master, often passed from parent to child or master to apprentice. The knowledge was embodied, intuitive, based on sensory observation rather than scientific measurement. Refrigeration seemed like an obvious improvement when it became widespread in the mid-20th century. In many ways, it was. Fresh meat tastes better than salted meat. Refrigeration requires less labor than preservation. It offers convenience that medieval methods cannot match. But the trade-off involved losses that most people never calculated. Traditional preservation required no ongoing energy input after the initial work was complete. A barrel of salted pork sat in a cellar for months without attention, without cost, without vulnerability to power outages or mechanical failures. Refrigeration requires constant electricity. When systems fail, whether from storms, infrastructure problems, or simple mechanical breakdown, food spoils within days. The convenience created dependence. The decline of preservation knowledge accelerated remarkably fast. Within a single generation, skills that had been common household knowledge became obscure. People forgot how to judge proper salt coverage, recognize beneficial versus harmful mold, maintain appropriate storage conditions, or time processes correctly. The knowledge wasn't taught because it seemed unnecessary. Why preserve meat when you could buy it fresh weekly? Industrial food production changed economic calculations as well. When meat could be transported quickly in refrigerated trucks and sold in supermarkets, the labor-intensive work of home preservation made less financial sense for individual families. It became cheaper to buy fresh meat regularly than to slaughter an animal once or twice per year and preserve it. Convenience replaced self-sufficiency, and with that replacement came vulnerability. Modern supply chains depend on uninterrupted electricity, functioning transportation networks, and stable distribution systems. When any link breaks, whether from natural disaster, infrastructure failure, or supply disruption, fresh meat becomes unavailable quickly. Grocery stores carry minimal inventory. Most households have no backup plan. Medieval preservation methods, in contrast, were resilient by design.
You have to listen to the ham.
Yeah. Listen to it.
They worked in crisis, in poverty, in isolation. They required only salt, time, attention, and knowledge. Traditional meat preservation hasn't disappeared entirely, though it has become specialized and expensive. Artisan charcuterie makers still produce prosciutto, country ham, salami, and dozens of other preserved meats using techniques that date back centuries. These products command premium prices not because the ingredients are costly, but because the knowledge and time required are rare. A properly aged prosciutto represents 18 months of careful attention and specific environmental conditions. Industrial food production cannot replicate this efficiently, so it remains artisanal. Some communities never fully abandon traditional preservation. In rural parts of Italy, Spain, France, and Scandinavia, families still cure their own meats using methods passed down through generations. These aren't historical reenactments or hobbyist projects. They're living practices maintained because people recognize their value, both practical and cultural. The knowledge persists in specific locations where it has remained relevant. The principles behind medieval preservation extend beyond meat. Salt, smoke, fat, and controlled drying work for fish, cheese, and some vegetables. The fundamental insight that reducing moisture and creating hostile environments for bacteria allows food to remain edible long-term without refrigeration applies across food categories. Understanding one preservation method makes others more accessible because the underlying logic remains constant. For modern people interested in resilience, food security, or simply understanding how human societies functioned before industrialization, these techniques offer practical options. Learning to salt cure meat doesn't require exotic equipment or expensive ingredients. It requires salt, a cool storage location, and attention to detail. The same applies to smoking or making confit. These aren't skills beyond ordinary capability. They're skills that ordinary people practiced routinely for centuries. Medieval meat preservation succeeded not because people lacked alternatives, but because they developed sophisticated systems refined over generations. These techniques worked through sound chemical and biological principles that remain valid today. Salt draws moisture from meat and kills bacteria through osmotic pressure. Smoke deposits
See the color change right here?
compounds
That
actively
is
resist
what you
decay.
want.
Fat creates airtight seals, preventing oxidation. Controlled drying concentrates nutrients while eliminating the water that bacteria require. Each method addressed specific challenges and offered particular benefits. The knowledge required wasn't trivial. Successful preservation demanded understanding of how temperature, humidity, salt concentration, and time interacted with different types of meat. It required recognizing signs of proper curing versus spoilage, knowing when to adjust methods based on conditions, and maintaining environments that supported preservation over months. This knowledge was rarely written down. It lived in practice, taught by example, refined through experience. Modern refrigeration offers undeniable convenience, but it creates dependencies that traditional preservation avoided. When preservation knowledge is lost, people become entirely reliant on systems outside their control. When that knowledge is maintained, households have options. They can preserve abundance for future scarcity. They can maintain food security without continuous energy inputs. They can practice skills that connect them to centuries of successful human adaptation. The pig slaughtered in November 1450 fed a family through winter, spring, and into early summer. The meat stayed safe because people understood principles that most modern households have forgotten. Those principles weren't magic or luck. They were systematic applications of observation and experience. Technology changes. Knowledge, once learned and maintained, endures.